So hello everyone, today I have a question for you all from rotational mechanics. Yes, so the question says, I'm not writing the question, only the cases I am writing. So the question says that there is a disk of some mass small m and radius is r. It is rotating about the axis passing through the center of mass and perpendicular to the surface. Yes, and it is rotating with some velocity omega 1. Yes, this is case 1, and case 2 is that same disk of mass m, radius does not change r, but we have put two small spheres of 0.5 m mass that is diametrically opposite. Yes, these the two are diametrically opposite ends. Yes, these two are diametrically opposite ends, and now it moves with omega 2. So we have to find what is the value of omega 2. Yes, we have to find what is the value of omega 2. So I hope you understand the question and also get what law should we use. Yes, so we should use law of conservation of angular momentum. Why? Because from this case to this case, we we know that there is no external torque. There is no external torque. External torque is 0. Therefore L equals to constant. L is angular momentum in case 1. In case 2, both should be equal. Yes, both should be equal. So I1 omega 1 should be equal to I2 omega 2. What is I1? This is a circular disc. Yes, circular disc. For circular disc, I is mr square by 2 omega 1. Now for this also mr square by 2, but since these two masses are also added to this, we have to calculate the moment of inertia of these two also, and we have to add all we need to is add. Yes, because moment of inertia is a tensor quantity, and tensor quantity are like scalars ones. Yes, they are added or can they are added or can be subtracted as scalars. So here we have to add them. Yes, because they are added. Okay. So 0.5 m r square whole twice. I hope you understand this. What I have written just now. 0.5 is the mass into perpendicular distance to the axis of rotation. Yes, from the axis of rotation, that square, and two masses, so multiplied with 2. The whole system is moving with omega 2 angular velocity. So mr square by 2 omega 1. Now we have to just simplify the things. 0.5 into 2, 1. So mr square by 2 plus mr square whole omega 2. Yes, whole omega 2. Now we just cancel these terms. Mr square by 2, mr square by mr square, mr square. Here we can cancel this. You can get that omega 1 by 2 is equals to 1 by 2 plus, I hope that's visible, 1 by 2 plus 1 times omega 2. So I'm writing it here. Omega 1 by 2 is equals to 3 by 2 omega 2. So you have to find omega 2. So omega 2 is like 1 by 3 omega 1, and that's the answer. Yes, 1 by 3. I'm writing it. Yes, so omega 2 is 1 by 3 omega 1. This is the solution and this is the answer, and we also check that answer. Why? Because we know that moment of inertia increases since angular momentum is conserved. Therefore the angular speed must decrease, and that's why angular speed is one third of the angular speed in case 1. So our answer is correct. Yes, so what we have to use is that Angular momentum does not change in case 1 and in case 2 because there is no external torque. That's all. That's all for this question. Thank you very much.